Absolutely, there is life elsewhere, and almost certainly intelligent life. It has to be, the odds are just overwhelming. A recent revelation has sparked intrigue and wonder among scientists and space enthusiasts alike. Renowned science communicator Bill Nye caused a stir when he revealed that Voyager 1 had detected 300 massive objects in space. This revelation has not only piqued our collective imagination but also sparked profound questions. So what are these objects, and where do they come from? Come along as we unravel the mysteries hinted at by Voyager 1's astonishing revelation. For nearly 50 years, the Voyager missions have given us some of the earliest and most remarkable views of our solar system's wonders. Surprisingly, these missions were not built to last so long. In the 1970s, Michael Minovich had a breakthrough idea: a spacecraft could use a planet's velocity to propel itself further into the solar system. Initially planned to last only 5 years, the Voyager mission has far surpassed these expectations. Voyager 1 and Voyager 2, launched just weeks apart in the summer of 1977, were first set to explore Jupiter and Saturn. They achieved this mission by successfully studying these gas giants, but they didn't stop there. Voyager 2 went on to make the first ever close-up observations of Uranus in 1986 and Neptune in 1989. These flybys of 4 planets earned the mission the name Voyager Grand Tour. Instead of ending their mission, the resilient Voyager spacecraft set their sights on an even more ambitious goal: exploring deep space. Now, 46 years later, Voyager 1 and Voyager 2 are still traveling, gathering essential scientific data from the far reaches of the cosmos. In a groundbreaking announcement in 2013, NASA revealed that Voyager 1 had officially entered interstellar space. Interstellar space is the region between stars, beyond the influence of the sun's particles and magnetic fields. It's like moving from a busy solar system into a peaceful, star-filled wilderness. The Voyager story continued in 2018 when Voyager 2 also entered this vast region, 17.7 billion kilometers away from the Sun. Remarkably, Voyagers 1 and 2 are the only spacecraft to have ventured into interstellar space. These pioneering spacecraft have been studying how the interstellar medium interacts with the solar wind from our Sun. NASA's Voyager 1 and 2 spacecraft have been our primary source of information regarding the heliosphere, a protective shield enveloping our solar system. The heliosphere is shaped and adjusted by the solar wind, a continuous stream of charged particles emitted by the Sun. Voyager 1 and 2 have acted as our cosmic reporters, sending back valuable insights about this celestial shield. Where does all this information converge? At the heliopause, the official boundary of our solar system, marking the transition from the solar wind to the vast expanse of interstellar space. NASA's Voyager spacecraft has provided valuable new knowledge about interstellar space. One significant finding is that cosmic rays, mysterious particles, are 3 times more intense beyond the heliopause compared to within the protected area of the heliosphere. This difference is like comparing the tranquility of a backyard to the bustling activity of a busy street. However, there's more to this cosmic drama. NASA's experts didn't stop with Voyager discoveries; they integrated data from subsequent missions with Voyager's observations, creating a comprehensive portrayal of our Sun and its complex interaction with the surrounding interstellar space. In a grand cosmic performance, NASA scientists made a surprising revelation last year. Voyager 1 captured a low humming sound that matched the vibrations detected in small amounts of gas floating in the vast emptiness of interstellar space. Nicola Fox, the leader of NASA's Heliophysics Division in Washington, D.C., stressed the importance of the Voyager missions. In her words, over the past 46 years, the Voyager missions have been crucial in providing us with this knowledge and have changed our understanding of the Sun and its effects in ways that no other spacecraft can. Now, that's quite an adventure in space. Voyagers 1 and 2 rely on a power system fueled by plutonium. However, as the plutonium ages, it produces less heat, causing the Voyagers to lose power. Facing this cosmic challenge, NASA had to make tough choices, shutting down non-essential systems and even some initially deemed necessary. The heaters meant to keep instruments warm in the freezing expanse of space were turned off. But here's the surprise: despite the odds, all 5 instruments have been functioning well since 2019, defying expectations. NASA experts are puzzled, wondering how the Voyagers are still operating in temperatures that would normally freeze other spacecraft. It's a mystery that deepens the remarkable legacy of these brave space pioneers, adding another layer of wonder to their enduring journey. The outer edges of our solar system are surprising astronomers with unexpected behavior. The heliopause, which acts as a boundary between our sun's influence and the space between stars, is not staying still. Instead, it's moving and creating strange angles, leaving scientists amazed and puzzled. This idea of the heliopause changing shape isn't entirely new. For the past 10 years, smart researchers using data from Voyager 1, Voyager 2, and NASA's Interstellar Boundary Explorer satellite have noticed the heliopause's tendency to change. These spacecraft are incredibly important as they give us direct measurements of these cosmic borders, even though it's just at one specific spot in space and time. Dr. Eric J. Azern, a space physicist at Princeton University, shared some exciting insights in an email to Vice. He mentioned how IBEX, another satellite, is adding valuable data to help scientists make better predictions about the heliopause's future movements. Now here's where it gets more interesting. Recent studies have challenged what we thought we knew. IBEX noticed a strange brightening of energetic particles in 2014, suggesting some irregularities in the heliopause. However, these irregularities didn't match our existing models, almost like a surprise twist in a story. Moreover, researchers saw significant changes in the heliopause's position in a short time after studying data from Voyager 1 and Voyager 2. This movement might explain why these two probes reached interstellar space in 2012 and 2018, respectively, with a big gap in between. These unexpected behaviors are not just confusing, they contradict what we thought we understood about the heliopause. In a recent article in Nature Astronomy *, scientists referred to these discrepancies as intriguing, meaning they are puzzling and could cause some debate in the scientific community. But don't worry, the search for answers continues. Scientists are eager to learn more from NASA's upcoming Interstellar Mapping and Acceleration probe, scheduled to launch in 2025. This advanced satellite promises to reveal more secrets about the outer reaches of our solar system. Until then, we can only wonder about the mysteries waiting for us beyond the heliopause. On May 2023, Voyager 1 experienced an unusual event during its regular operations. The part of the spacecraft responsible for controlling its high-gain antenna, known as the Attitude Articulation and Control System (AACS), started sending back confusing data. Instead of the usual updates on the spacecraft's health and status, it seemed like Voyager 1 was having trouble communicating effectively, similar to how someone might struggle to speak fluently due to a condition like electronic aphasia. From our perspective on Earth, it appeared that Voyager 1 was experiencing electronic confusion. The data it sent back seemed random or lacked coherence, as NASA explained at the time. Interestingly, despite these strange reports, Voyager 1 appeared to be functioning perfectly fine. Its radio signal remained strong and stable, indicating that the antenna was still pointing toward Earth, contrary to what the AACS was indicating. Adding to the intrigue, Voyager 1 scientific instruments continued their operations without any issues, unaware of the anomaly in the AACS. Furthermore, the spacecraft's fault protection system, designed to respond to glitches by putting the spacecraft in safe mode, was not triggered by this event. Fortunately, NASA quickly identified the problem. It turned out that the AACS was using a computer that had been inactive for a long time. The solution was simple, a command to switch to the working computer for data transmission. However, the mystery remained about what caused the AACS to act strangely in the first place. NASA suspected that an incorrect command from another onboard computer might have triggered it. While this incident didn't pose a significant risk to Voyager 1's safety, NASA is actively investigating to prevent similar occurrences in the future. Voyager 1 has been exploring interstellar space for over a decade, outside the protective magnetic field of the Sun. This magnetic shield, similar to Earth's magnetic field, shields the spacecraft from cosmic rays and other space radiation, acting like a cosmic suit of armor when it comes to technology. Just as Earth's computers can face challenges from high-energy particles and solar radiation, Voyager 1 is also susceptible to these cosmic. Voyager 1's onboard computers also encounter cosmic hurdles. Sometimes energetic particles can interact with computer chips, leading to small memory errors that build up over time. Susan Dodd, the project manager overseeing both Voyager 1 and 2, provides a cosmic perspective on these challenges. She mentions that encountering such mysteries is part of the norm at this stage of the Voyager mission. These spacecraft have been on an incredible journey for nearly 5 decades, far exceeding their expected mission duration. It's worth noting that they are navigating through interstellar space, an environment filled with high levels of radiation, a territory no spacecraft has ever explored before. Nearly 50 years have passed since Voyager 1 and Voyager 2 set off on their remarkable journey. They've traveled across vast distances, delving into unknown realms and uncovering groundbreaking knowledge. These iconic spacecraft, now venturing into interstellar space, face a unique challenge. Their computer systems from the 1970s era operate with just 70 kilobytes of memory. Yes, that's right, a mere 70 kilobytes. Despite these technological limitations, NASA has successfully maintained the functionality of these distant explorers. Just imagine the effort of sending software updates across immense cosmic distances to ensure their ongoing operation. It's akin to providing cosmic IT support. Consequently, amidst the vast darkness of space, billions of miles away from Earth, the Voyager probes have crossed significant thresholds, offering humanity profound insights into the mysteries of our solar system. Let's pause for a moment to honor these trailblazing space pioneers, the twin Voyager probes. They are currently bidding farewell to our solar system, drifting endlessly amidst the stars. Each probe is comparable in size and weight to a small car. They are akin to vintage legends of space exploration, embodying the technological essence of the 1970s. True, their computer systems may be less powerful than today's digital watches, and their analog TV cameras may seem primitive compared to modern ones, but they have left an indelible mark on every celestial body they encountered. Thanks to the Voyager spacecraft, we've learned fascinating details about Jupiter. It's not just a calm giant, it's a planet of extremes, with hundreds of fierce hurricanes, a glowing aurora at its north pole, and 3 delicate rings that are more intricate than a fancy braid. Similarly, Saturn surprised us. Its rings, once thought to be few and simple, turned out to have thousands of ringlets and braided structures that were thought impossible by experts. What's more surprising is the discovery of active volcanoes, which were previously believed to be unique to Earth. These volcanoes were found on Jupiter's moon Io and, amazingly, on Neptune's moon Triton. On Triton, nitrogen geysers erupted at temperatures as low as 40 degrees above absolute zero on the Kelvin scale, adding to the astonishment. But the most captivating find was the identification of potential hotspots for alien life. 2 of Jupiter's moons, Europa and Saturn's Enceladus, appear to have vast salty oceans beneath their icy surfaces. These oceans could potentially harbor living organisms, making these moons prime targets for further exploration. The Voyager mission bid a heartfelt farewell with a touching tribute to where it all began. In the early 1990s, the spacecraft captured a snapshot of our solar system, including Earth, thanks to an idea proposed by Carl Sagan, a key figure in the Voyager imaging team and the genius behind the Golden Record back in 1981. This iconic image of Earth became known as the pale blue dot, as coined by Sagan himself in his book of the same name. Sagan was inspired by the breathtaking Earthrise pictures from the Apollo program, especially the one taken by Apollo 17 from the moon's surface. His goal was to offer a new perspective, showing Earth from a distance 100,000 times farther away, believing that such an image could help us understand our place and situation in the grand scheme of things. While ancient philosophers viewed Earth as a tiny speck in the vast universe, this perspective had never been visually experienced until that moment. Fast forward to August 25, 2012, Voyager 1 made history by crossing into the interstellar medium at a mind-boggling distance of 11 billion miles from the Sun. Remarkably, it continues to send valuable data back to us. Its counterpart, Voyager 2, joined the interstellar journey in 2018. These pioneering spacecraft are now so distant that it takes about 22.5 hours for a radio signal traveling at the speed of light to reach Voyager 1 from Earth, while Voyager 2 requires nearly 19 hours. Each day, these brave probes move another 3 to 4 light seconds away from us. NASA's Deep Space Network, consisting of 3 tracking complexes located strategically around the world, serves as their lifeline, ensuring continuous communication even as Earth rotates. As our spacecraft venture further into space and time, their signals become faint whispers. The Earth's bustling noise from radios, TVs, cell phones, and other sources makes it quite difficult to pick up these faint signals. Despite their faintness, these whispers align with astronomers' expectations as the Voyagers move into the interstellar part of their mission. This mission, a massive scientific endeavor spanning around 10,000 workers, is widely regarded as one of our species' most significant explorations. Interestingly, it almost didn't happen. The Voyager mission was a stroke of luck in celestial mechanics. Initially, Michael Minovich discovered that spacecraft could gain speed from a planet to move away from the Sun. Building on this, Gary Flandreau demonstrated that probes launched during the late 1970s and 1980s could utilize a special alignment of outer planets, utilizing gravitational assist to travel faster. This revelation made Neptune, situated at the solar system's edge, reachable in just a dozen years instead of the anticipated 30. NASA seized this opportunity, although budget constraints led to scaling back the grand tour of the outer solar system. Consequently, instead of an extensive exploration, they opted for a more affordable visit to Jupiter and Saturn, still amounting to a $250 million journey. Researchers were hopeful for a detour to Uranus and Neptune, banking on Voyager 1's success at Jupiter and Saturn to adjust Voyager 2's trajectory for these planets. Let's delve into the equipment. The twin Voyagers were equipped with advanced instruments like cameras, infrared and ultraviolet spectrometers, sensors for mapping cosmic particles like charged particles and cosmic rays, along with a photopolarimeter and a magnetometer. Powered by nuclear energy, these spacecraft were initially expected to operate for about 5 years. However, they exceeded expectations, extending their lifespan tenfold. Over time, the Voyager mission has transformed into a legendary expedition to the outer planets and beyond. It's not just a scientific endeavor but a symbolic journey blending myth and science. The mesmerizing images of distant worlds captured by these spacecraft turned the mission into a historic quest into the unknown. And then there's the Golden Record, a standout feature. Each Voyager carried a phonograph record filled with images, music, and sounds representing Earth, including greetings in 55 languages. It served as a cosmic message to any intelligent beings in the Milky Way, a hopeful communication across vast distances. The thought of extraterrestrial civilizations encountering these messages stirs excitement, offering us a glimpse of galactic recognition and potential immortality. The Voyager mission symbolizes our profound curiosity about the cosmos, resonating with participants and observers alike, and reflecting our collective desire to understand our cosmic significance. For more than 10 years, the diligent work of these twin spacecraft has allowed humanity to explore the mysteries of space between stars. The probes sent by NASA have not only given us valuable knowledge about our solar system but also uncovered the unusual and surprising aspects of space beyond our Sun. Let's break it down. Despite appearing calm as a glowing ball of light, our Sun is a dynamic nuclear furnace zooming through the galaxy at an incredible speed of 450,000 miles per hour. The Sun is surrounded by twisted, tangled magnetic fields. As it moves around the center of our galaxy, constantly, the Sun releases a flow of electrically charged particles called the solar wind. Now, here's where it gets interesting. The solar wind doesn't just vanish into space. When the solar wind clashes with the interstellar medium, which is a mix of remnants from old star explosions floating between stars, it creates a fascinating phenomenon. Imagine it like oil and water colliding. They don't blend perfectly. Instead, the solar wind forms a protective bubble within the interstellar medium known as the heliosphere. Thanks to data from the Voyager spacecraft, we now understand that this heliospheric bubble stretches an enormous 11 billion miles from the Sun at its leading edge. It envelops the Sun, all 8 planets, and many objects orbiting far from our star. This heliosphere is not just for decoration, it acts as a shield, safeguarding everything inside, including our fragile DNA, from most of the galaxy's intense radiation. Picture it as a protective shield ensuring the safety of our solar system amidst the vastness of space between stars. To solve these cosmic mysteries, it's essential to fully grasp the heliosphere. That's why NASA plays a role similar to cosmic tech support, ensuring that these distant explorers remain operational by sending software updates across immense distances. It's akin to performing surgery on a patient located an astonishing 15 billion miles away, definitely not your typical Monday morning task. Updating Voyager's software is far from simple. It involves sending new instructions directly to the spacecraft's computers, which are programmed to understand the most basic form of programming known as machine language. This means the instructions must be written in a language that the hardware can comprehend without the help of an operating system or advanced programming tools. To tackle this challenge, NASA engineers use a combination of creativity and resourcefulness. They utilize assembly language, a programming language similar to machine code, to create the update instructions. This approach gives them direct control over the hardware, ensuring that the code runs as efficiently as possible. Additionally, they use pseudocode, a simplified set of commands that automate repetitive tasks without consuming too much memory. These software updates are not just about fixing bugs, they are crucial for the survival of our brave spacecraft. Over the years, these updates have addressed various problems, from fixing malfunctioning parts to resolving memory issues. For example, a software update once saved Voyager 1 from a potential disaster when a hardware component stopped working, activating a fail-safe mechanism that allowed the spacecraft to continue its mission in space. The Voyager missions were far from routine journeys, they marked the beginning of numerous interstellar adventures. These missions not only made groundbreaking discoveries but also inspired further exploration into the unknown realms of space. When the Voyager spacecraft took a closer look at Jupiter, it revealed the planet's intricate nature, sparking great enthusiasm at NASA. This led to the launch of two significant missions, Galileo in 1989 and Juno in 2011. You could think of Voyager as the precursor to these major space missions. But that's not all. Voyager's exploration also inspired the renowned Cassini mission to Saturn. Jonathan Lunin, a prominent planetary scientist at Cornell University, credits Voyager 1's detailed flyby of Titan, one of Saturn's moons, as the driving force behind Cassini's remarkable mission. Cassini even deployed a probe named Huygens onto Titan's surface in 2005, capturing stunning video footage. Voyager 2 also made significant contributions by initiating studies into the icy giant planets, not only within our solar system but also in distant star systems. Consider this: many of the exoplanets we've discovered so far share similarities with Neptune and Uranus in size, and Voyager 2 played a role in this cosmic exploration. Fast forward to the present day, and NASA continues to build upon Voyager's legacy. The Dragonfly mission is scheduled to land on Titan, Saturn's largest moon, in 2034. The Europa Clipper mission is preparing to investigate Jupiter's moon Europa, first observed by Voyager, starting in 2030. Additionally, the National Academy's Planetary Science Survey proposed a $4.2 billion mission to Uranus with an orbiter and probe in the 2040s. This mission represents a significant encounter with the enigmatic ice giant and its moons, all tracing back to Voyager 2's brief encounter with the Uranus system in January 1986. Nearly 5 decades have passed since Voyager 1 and Voyager 2 began their incredible journey through space, yet their impact is still felt today. These spacecraft set off a chain of curiosity and discovery that continues to unfold. Here's the latest update: both Voyager 1 and Voyager 2 are still communicating with NASA's Deep Space Network. This network, initially intended for communicating with Voyager 2 during its missions at Uranus and Neptune, is still receiving instructions and sending back data to Earth. This enduring connection is quite remarkable. Estimatio Crimmins, the lead scientist for the Voyager 1 and 2 missions, shared these updates during a recent news conference. He mentioned that we are still collecting valuable data from the Voyager spacecraft, and the plan is to continue this interstellar exploration for another 5 or 6 years. However, by the mid to late 2020s, the scientific instruments on these spacecraft will be turned off, and they will become silent and inactive. Nevertheless, their journey into the vast unknown of space will continue indefinitely. Crimmins, who is in his 80s, humorously remarked that he hopes to outlast the Voyagers, although he's unsure if that will happen. In about 300 years, both Voyager 1 and Voyager 2 will enter the Oort cloud, a region filled with comets surrounding our solar system. After another 30,000 years, they will depart from our solar system and orbit the center of the Milky Way for millions of years. Although their scientific missions will wind down, the Voyagers' incredible odyssey through the cosmos is just beginning. While the Voyagers continue their journey, NASA's Hubble Space Telescope, an experienced observer at nearly 33 years old, is still making stunning discoveries. In a recent image, Hubble captured the radiant glow of a distant spiral galaxy called MCG plus 01-12-024, located about 275 million light-years away. This galaxy is unique, with its two spiral arms and an active galactic nucleus at its core. MCG plus 01-12-024 falls into the category of Type II Seyfert galaxies, known for their bright cores, though less intense compared to quasars. It's like a cosmic show, with galaxies revealing their secrets, each adding to our understanding of the vast universe. MCG plus 01-12-024 stands out because of its unique light. In astrophysics terms, it's a bit of a surprise. Normally, when we look at the light patterns from atoms and molecules, they follow certain rules. But in space, there are lines in these patterns called forbidden emissions that don't play by the rules. It's as if they're rebelling in a cosmic sense. Why are they called forbidden? Well, on Earth, according to the neat rules of quantum physics, these emissions are so unlikely that we usually don't pay attention to them. But in the active center of a galaxy, things are different, and the forbidden light gets a chance to shine toward us. That's what the Hubble telescope captured in a photo. This picture, taken by Hubble's advanced camera, shows MCG plus 01-12-024 as the star of the cosmic show. There are also two bright stars in the foreground, one blue and one red, that add some sparkle. If you look closely, you can also see more distant galaxies in the dark space background. It's like a stunning piece of celestial art, reminding us of the Hubble telescope's ongoing contributions to our understanding of the cosmos. While you're still here, be sure to click the video on your screen to see more mind-blowing content like this one.